So I have here that Jack is in his final year of undergrad mathematics student at the University of Cambridge.
Yeah.
So welcome, Jack.
Hello, thank you for having me.
So do you want to tell us a little bit about yourself and what you'll be sharing with us today?
Yeah, so I'm as you said, final year undergrad at Cambridge in the UK. And today, my maths trick is going to be an astounding result, which I'm going to demonstrate on the whiteboard behind me.
Sounds wonderful. Do you need anything to get started? Any help from the audience?
Not immediately, but I will be posing the chat 2 questions once I've written the first thing. So
All right.
we'll get started with that. So the result I'm going to show you concerns this sequence. We'll call it S, and it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus, and so on. Now, my 2 questions for chat are, 1, can you see this okay on the whiteboard? And 2, what do you think this is going to work out as? If we evaluate this sequence, what do you think it's going to be? Now, I understand there's a 30-second delay in chat. So while we wait for that to come in, I'm going to briefly think, well, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, and so on. But surely it's infinity then. But are there not other numbers that it could be? Well, are we seeing any suggestions in chats yet?
Yes, so I'm getting -1 over 12, n plus 1 divided by 2, -1 over 12 plus infinity.
Okay.
A lot of -1 over 12.
Yes. So the -1 over 12 people know where I'm going with this, but we'll get to that. The person who put the n formula, that's really interesting, because if you terminate this sequence at any point, then that's exactly what you get. If you terminate it at 6, you'd get 6 times 6 plus 1 divided by 2. Terminates it 5 times 5 plus 1 divided by 2. But we're dealing with the infinite sequence here, so we're going to try and evaluate all of it. And first, to do that, I need help from another sequence, t, which I'm going to define as 1 minus 1 plus 1 minus 1 plus 1 minus 1, and so on. Now, this seems even harder to find a value for, because it doesn't clearly tend off to infinity, but it doesn't tend to anything. It looks like it could be 1, it looks like it could be 0. And you can get a whole host of other values depending on where you terminate it. But because it's an infinite sequence, we don't want to terminate it. We want to work with it as it is. So to find t, let's consider 1 minus t. And that is 1 minus 1 minus 1 plus 1 minus 1 plus, and so on. Well, this minus just flips the signs of everything in here. So we get 1 minus 1, minus minus 1 is plus 1, then minus plus 1 is minus 1, minus minus 1 is plus 1, and so on. 1 minus t. But that surely is just t again. So 1 minus t, t, let's add t to both sides. 2t is 1. So t is a half. Now, I'm going to leave that result at the top of the board because we need it for the next result that we need to prove this mad trick. So we'll put that back at the top of the board. T equals 1 minus 1 plus 1 minus 1 plus 1 minus 1, which is a half. Now, let's consider u.
Jack, I think you might need to write a little bit bigger if you don't mind.
Okay, let's consider u, which is another sequence that we're going to define. Now that is 1 minus 2 plus 3 minus 4 plus 5 minus 6, and so on. Now this looks kind of like t and kind of like s. It's sort of a midpoint between the two. And in fact, this is going to help us get between the two, because here's u. What if I tried to evaluate 2u? Well, 2u is u plus u, so we need to add on a u. But I'm going to do it in a different way. I'm going to move it along slightly. So I'm going to add it here. The 1 goes below the 2. The minus 2 goes below the 3. The plus 3 goes below the minus 4. The minus 4 below the plus 5. And the plus 5 below the minus 6, etc. So that's 2u, which is, the 1 stays the same. Minus 2 plus 1 is minus 1. 3 minus 2, 1. Minus 4 plus 3 is minus 1. 5 minus 4 is plus 1. Minus 6 plus 5 is minus 1. 2u is t. But we know what t is. T is a half. But if 2u is a half, then u is a quarter. And that's another result that I will keep at the top of the whiteboard. So already we've proved some very strange things about these infinite series, because already these are things that we didn't seem to have any value, that we have now assigned value to. Now, finally, we come to the thing we wanted to show, s. But I'm going to consider s minus u, because that is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus, and so on, minus 1, because it flips the signs, does the minus. We get minus 1 plus 2 minus 3 plus 4 minus 5 plus 6, and so on. That is 1 minus 1 is 0. 2 plus 2 is 4 plus 3 minus 3 is 0. 4 plus 4 is 8. 5 minus 5 is 0. 6 plus 6 is 12. And this pattern would continue. That's 4 times 1 plus 2 plus 3 plus etc. That's 4s is equal to s minus u. But we know what u is. U is a quarter. Rub it out here and put a quarter. S minus a quarter is 4s. Now let's take s from both sides. 3s minus a quarter. So s is minus a 12. So all the people putting minus a 12 in chat, are they correct? It would appear so from here. But there is another thing that we can do to s. Because this was quite convoluted to get to s's minus a 12. I did a lot of things. But can we not do much more simple things to s to get a result? Well, we can start messing about with it and see what we come up with. So, in particular, we have s is 1 plus, and then we can group the terms. 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus, and so on forever. For that, it's 1 plus 2 plus 3 plus 4 is 9. 5 plus 6 plus 7 is 18, and so on forever. The next term would be 8 plus 9 plus 10, which is 27. You have a calculator, you can play along at home. But 9 plus 18 plus 27 plus, and so on, and so on, is just 9 times 1 plus 2 plus 3 plus 4 plus, etc. It's 9 times s. S is 1 plus 9s. So we can rearrange this again. Take 9s from both sides. Minus 8s is 1. S is minus an eighth. So now all the people who put minus a 12th in chat are like, whoa, it's also minus an eighth. But is it? Well, clearly something's gone wrong. And indeed, there are reasons why it might not be either of those. But first, I want to show you another way to get minus an eighth. Because we can group even more terms. Do S is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12 and so on, which is 1 plus 2 is 3. Again, play along at home with your calculators for this bit. 3 plus 4 plus 5 plus 6 plus 7 is 25. 8 plus 9 plus 10 plus 11 plus 12 is 50. And the next one would be 13 plus 14 plus 15 plus 16 plus 17, which is 75, and so on. But this, again, 25 plus 50 plus 75 plus 100, and so on, that's 25 times 1 plus 2 plus 3 plus 4 plus 5, and so on. So S is now 3 plus 25S. Take 25S from both sides. Minus 24S equals 3. And again, dividing by minus 24, we get S equals minus an eighth. So we've got two different methods. One gives minus a 12th, and one gives minus an eighth to a sequence that is obviously infinite. But what's going on? And I would like to give the viewers a moment to think about that. So while we're doing that, we could shout out the charity information again, or something similar. It's the What's On-a-thon is the people we're in partnership with. What's the donation link? Do you have it to hand?
Yes, I'll go ahead and post it in the chat. So, Jack, if I can comment, you did the math behind this is all interesting, but how did you memorize all of it? It just seems so convoluted.
I'm familiar with this trick from being quite young, so it kind of just stuck with me when I first saw it, because I was like, whoa, it's minus a 12th, and I just kind of committed it to memory because I thought it was so cool.
Fair enough.
Yeah.
Not seeing too much in the chat about. Someone just said it's mathematical hocus pocus trickery. Is that correct?
It is indeed mathematical hocus pocus trickery, but why?
Someone's just saying their mind is blown. Never seen. Negative 1/8. Associative and commutative only holds up for finite sequences. I'm not seeing too many guesses in the chat.
Now, the person who put associative and commutative only holds up for finite sequences is onto something, because putting those brackets around the sum for minus an eighth only made sense because it was all pluses. But we know that works for a finite sequence. But why did we assume it works for an infinite sequence when we know that if we had like anything else other than just pluses, even in a finite sequence, it wouldn't work? And this hits right at the heart of the problem here, which is that we can't extrapolate our understanding of finite sequences to infinite sequences. You can't just put brackets in an expression without changing its value. And this is true for a lot of finite sequences as well. Anything that involves BIDMAS, order of operations, would not work. What do you call it in America? Is it PEDMAS, the American children?
PEMDAS.
PEMDAS, yes. Yeah, so that kind of immediately looks to disprove the minus an eighth answers. But what about the minus a 12th answers? Well, that's a bit more complicated, because it seems difficult to disprove any individual step within that sequence. And indeed, I wasn't I didn't understand how to even go about disproving them until I was at university. In my first year, we did a course called Analysis 1, which talked about a lot about this. So if you are interested in this viewer at home and are thinking of studying maths at university, then an analysis course could be for you if you are interested in this kind of stuff. But I do want to focus on one step in the minus a 12th thing, which is we had at one point s minus a quarter equals, it was 4s, I believe. Yes, 4s. Okay. Now, if we were solving this normally, then we would do what I did. Take s from both sides and then divide by 3. But we have to assume what values are we allowing for s. It's not just the regular numbers, because we have an inkling it might be infinite. So we need to allow infinite to be one of the values that it will take, because otherwise we'll never find it doing this kind of arithmetic. And indeed, if we take s to be infinite, then we can see that the left-hand side here, s minus a quarter, would be infinite. And the right-hand side, 4s, would also tend towards infinity. So maybe they are equal, even if s is infinite. And we see similar lines in the ones for minus an eighth as well. I believe the first one had s equals 1 plus 9s, which, again, if s tends towards infinity, then 1 plus 9s also tends towards infinity. And we also have s equals 3 plus 25s in the other one, where if s tends towards infinity, then 3 plus 25s tends towards infinity. When we allow infinity in the set of possible solutions, then we can't just ignore it when we come across it as a possible solution for an equation. Now, I understand this is quite a boring conclusion to this bit, that the mind-blowing answers are actually not true. So I want to end with a result from physics. Because in physics, you can't have infinity as any of your answers. So if you came across that s equals, if you came across that s equations, the s minus a quarter equals 4s, you would have to conclude that it equals minus a 12, because you can't have infinite stuff in physics because nothing in the real world is infinite. But despite this, that infinite series, 1 plus 2 plus 3 plus 4, etc., actually comes up. Now, I don't know how many kind of older viewers we have in the audience, but if you're like 16, 17, 18 doing kind of that level of physics, then you've probably come across the idea of energy levels. And for those that haven't, understanding the concept is not entirely important to this final bit. I hope you can still follow along. But essentially, in physics, a particle can take an energy level. And this is essentially how much energy it has. And in string theory, a particle at energy level n has energy E equals n h bar omega d minus 2 over 2. N is the energy level. We don't need to worry about what h bar and omega are. D minus 2 is the number of dimensions. But D, is the number of dimensions that your space has, because physicists, particularly in string theory, like generalizing to higher dimensions. Now, I apologize if there's any real physics buffs in the audience, because I am hugely oversimplifying it, and they are probably quite cross about that. But stick with me. In string theory, a particle can take multiple energy levels at the same time, and indeed all the energy levels at the same time. This is because it has what's called harmonics, which are at different energy levels, but represent the same particle. So with that, you just add the energy levels together to get the energy of the particle. So if it's taking all the energy levels, then that would be 1 times h omega d minus 2 over 2 plus 2 times h omega d minus 2 over 2 plus 3 times h omega d minus 2 over 2, and so on. But now we can take out a factor of this h omega d minus 2 over 2 to get that the energy of a particle taking all energy levels because of its harmonics, which is allowed in string theory, would be h omega d minus 2 over 2 times 1 plus 2 plus 3, and so on. But we know what this is. This, because it's physics, can't be infinite. It has to be minus a 12th. So this energy is minus a 12th times this. And that is minus h omega d minus 2 over 24. But there's also a result in this particular type of string theory that this would be equal to minus h omega, which means, since we have that here, that d minus 2 over 24 must equal 1. So d minus 2 is 24, so d is 26. Now, there's quite a famous result that people use to say that string theory is not true, that it only holds in 26 dimensions. And this is why. It's because this sum can be evaluated to minus 1/12. That this result in string theory that suggests it doesn't work is true. Now, that's astounding. That a result that can't mathematically be possible crops up in physics like this. I absolutely love this kind of thing. But I won't go into any more physics because I feel like that got a little complicated. Well, that's all I have for the trick, I'm afraid.
Well, that was very interesting. Not gonna lie, I was a little lost, but it was still a lot of fun to watch you work that out. I see a lot of people saying something that you just proved string theory wrong, and someone kind of shocked that there's only 26 dimensions or something like that.
Yeah, so the end, I apologize, it did get a little complicated, but I hope some people in chat still liked it. But yeah.
Yeah, I think everybody enjoyed it. Some other people were asking about if you have a website or a YouTube channel.
I'm afraid I don't, because I'm just a student. I'm kind of starting out on this kind of thing. This is the biggest thing I've ever done in terms of outreach, I think. So just please.
Fair enough. Well, do you want to tell us what you're planning to do next? Like maybe some more outreach opportunities or continuing your studies after undergrad, I believe you said?
I'd like to obviously be involved in more outreach opportunities, and if you do have an opportunity, please get in touch. My email is jacklharrison1010@gmail.com. Because I am a student, I will most likely do things for free. So hopefully that will entice people. I'd like to do more outreach. I don't really know what I want to do next, but I'm scouting opportunities all over. So hopefully I'll end up doing something I like.
Wow. So how did you get started in maths? Like, was it from, you said that you discovered this when you were a little kid, but what got you really into it?
I don't ever recall not being into maths. I know that's quite a cop-out answer, but I just kind of took to numbers when I was a young toddler, and I was like, this is very cool, which is a bit of a weird attitude for a toddler to have, but that's the attitude I had. And it's a passion that just kind of stayed with me, and now I've studied at a university.
Oh, that's pretty good to be interested in it. Interested in maths at such a young age. Do you have anything else fascinating to share? Sorry, I apologize. I'm running a blank here as to what to ask you.
Yeah, that's fine. I apologize. My segment didn't quite fill the time. There's the charities. Yes, it's the Turn charity for people in need, and the comedians charity as well.
Yes, I'll go ahead and share about that
No.
again. That this
Yes.
show is inspired by and partnered with British comedian Mark Watson. Mark Watson's 24-hour comedy show, The Watsathon, and will be taking place at the same time. There is a link to donate, and it's going to, I think, I don't remember it verbatim, but it's performers and such that have lost opportunity to make money in these trying times.
Yes.
Um, uh, is it okay if your email goes in the chat? I think someone's asking that.
Yeah, that's absolutely fine. Yes.
Okay, yeah, someone behind the scenes was asking.
Yeah.
Um, well, if that's it, I guess we can move on to the next speaker, unless you have anything else left to say, Jack. I don't want to push you out, but I apologize if there's no more questions
I
to ask.
I think that's all I have. Yes, I'd be happy to give way to the next speaker.
All right, well, thank you so much, Jack. That was very interesting.